This is section 12.2, and we're going to pick up two important rules in finding derivatives. The first one is the product rule. And if you have a function that is a product, u of x times v of x, the derivative is the first one times the derivative of the second plus the second times derivative of the first. So I always think of it this way. I don't try to memorize this. First times derivative of second plus second times derivative of first. And what I'm going to suggest to you, and especially if you have to show work on a question, I think a roadmap is the way to go, and that's what I try to do. So here's an example. You're given f of x is 2x plus 3 times 3x squared. Now we could multiply this out and then take the derivative, but we're trying to learn the product rule. So let's go ahead and do that. So when I say a roadmap, I want you to write out the rule, not taking any derivatives, just write out the rule. The first one times derivative of, so let's write d dx of the second plus the second times derivative of the first. So in this line, you're not doing anything except writing your roadmap. In the next line, all you do is take those two derivatives. This is the only place, these two yellow items are where you're taking the derivative. So this one's 6x, this one's just 2. So in this line, we got first times 6x plus 3x squared times 2. Then you're cleaning it up. So you multiply these two and get this, you multiply this and get this, add the 6x squared and the 12x squared, here's your answer. So that's the product rule. The quotient rule, a little bit more involved. If you have a quotient in your function, it's the bottom denominator times the derivative of the top minus, and I would always put this in brackets because that minus is going to change all these signs, and it's just best if you do it that way. Top times derivative of bottom over the bottom squared. So that's what we need to remember. Let's look at an example of that. So here we've got a quotient. So the first thing we're going to do is write out our roadmap, and I didn't have this highlighted. Let me highlight those two right there. Those are the only places that we are taking a derivative. So bottom times derivative of the top minus the top times derivative of the bottom all over the bottom squared. In this line, all we're doing is taking those two yellow derivatives. This one is 2, this one is 4. So that's what's there and here. All right, so we've done that in that line. Then we do the multiplying. So we've got 8x plus 6 minus 8x minus 4 all over that squared. The next line, we're going to take this minus and distribute it here. So we got rid of the parentheses, and that became minus 8x plus 4. Now the 8x and the minus 8x cancel out. We're left with 6 plus 4 on top and 4x plus 3 squared on the bottom. And that's how you would leave your answer. All right, so we've got 10 questions that you'll have on your homework. Let's go over some problems, and then you should be ready to tackle your homework. All right, number 1, y is equal to this product. First line, we're going to write out the roadmap. Y prime is equal to the first times derivative of the second plus second times derivative of the first. In the next line, all we're going to do is take those two derivatives. That one's 4. This one is 10x. So that's what's there and there. That's all we did in the third line. Then we're going to do this multiplying, and we got those. We'll collect like terms. So we had 60x squared minus 50x and plus 8, and that is our derivative. Number 2. Now, number 2, you have it, it's written like this, or 5x plus 6 times 5x plus 6. So it might be easier in this case to go ahead and just multiply this. So that's 25x squared plus 60x plus 36, because that's a real easy derivative. So that's 50x plus 60. You could do the whole product rule. In this one, I would say it would save you a lot of time to just do that. All right, number 3. Here is our product. We've got lots of negative exponents, that sort of thing. So it's real important to do our roadmap. P prime of y, first times derivative of the second, plus second times derivative of the first. Now we're going to take this derivative. Negative 3 times 4 is negative 12, and we're going to subtract 1 from the exponent, so that's negative 4 there. Negative 4 times negative 7 is a positive 28. We'll take 1 away from that exponent, and so that's our derivative. Plus that thing, and now we're going to take this derivative. Negative 1 goes to the front, y to the negative 2, because we take 1 away. Negative 2 comes to the front, and then that's a negative 3. So now we've taken all the derivatives. The rest is algebraic. We're going to multiply these two together and these two together, remembering that when you multiply, you're going to add exponents. So when you multiply this guy times this one, you get negative 12y to the negative 5. And then we'll multiply 28y to the negative 5 times that, and we get plus 28y to the negative 6. So you go through, you do your algebra, you get those, and then you'll just collect like terms. Negative 12 of those and negative 4 of those. So we have negative 16y to the negative 5. 28 of those minus 8 of those plus 7. So you collect all your like terms and you end up with this as your final answer. Number 4, a product. Here we go. We're going to write our roadmap. First, the bottom, times derivative of the top minus the top times derivative of the bottom over the bottom squared. That derivative is 6. That derivative is 2. So that's that line. Then we're going to do this multiplication. So we have 12x plus 6 minus 12x minus 14. When we take this minus and distribute it, that becomes a minus, that becomes a positive. Those two cancel out, so we're left with 6 plus 14 over that squared. There's your final answer. Number 5, we're doing the same thing every time. So I may not go over all of these. I mean, this one is just pretty much like the number 4. But do your roadmap. Take your derivative. There's 8. There's 2. Do the multiplication. Then distribute your minus. Those cancel. You're left with 18 over that squared. So that one's just like number 4. Number 6. Little bit more involved, but bottom times derivative. I didn't have my yellow here. I do like to have that. We'll get that there and there. All right, so bottom times derivative of the top minus the top times derivative of the bottom, all over the bottom squared. That derivative is 6x. That derivative is 2x. So that's there and there. We'll do the multiplication. We'll do that multiplication. Then we'll distribute this minus. We've got this. We'll collect all like terms, and we end up with that as our final answer. Number 7. Okay, this one is just got bigger. It's a bigger polynomial on the top, but we're still doing exactly the same thing. Here's where we're going to take a derivative. Here's where we're going to take a derivative. All right, so bottom times derivative of the top minus top times derivative of the bottom over the bottom squared. This derivative is 2x minus 6. This derivative is 2x. Then we'll do our multiplying and do our multiplying here. That's this line. Then we'll distribute the minus, which makes that minus, that plus, that minus. Those two cancel out. Collect your like terms. You're left with that trinomial over the bottom. Okay, now number 8, I think in the original lecture notes was a different type problem, but the new number 8, this will help you prepare for that. So we've got a quotient, but within the quotient, the numerator is a product. So either you could just do that product rule on top, but it might be easier to rewrite, go ahead and FOIL this. And so that's what I did here. So now I have that long polynomial over this. So here's my roadmap. Bottom times derivative of the top minus the top times derivative of the bottom. This derivative is 60x squared plus 70x plus 12, and that derivative is 9. All right, so then I took this here and I did that multiplication algebraically. This is one way to do it. You take the trinomial times the binomial, multiply 9x times all three of those, multiply -7 times all of those. They line up, so then you add just like an old-timey multiplication problem, and you get this. So now this yellow part will substitute for this. And then I did just multiply 9 times all of this. So down here, 540x cubed, got that business there, minus, that's where I multiplied it by 9. Then you distribute that minus sign to everything, collect all your like terms, and this is the answer for number 8. So it's a little bit more work, but I think you can handle that. All right, now number 9 and 10 also changed, and I've got them, let me get them separate. All right, here is the type question for number 9. That says number 1, don't worry about that. That is, this is number 9 in your work. So it says a psychologist contends that the number of facts of a certain type that are remembered after T hours is given by the following function. So we have this function, which is a quotient. Find the rate of change at which the number of facts remembered is changing after 1 hour and after 10 hours. So we find the derivative and then evaluate it at 1 and at 10. So this is all the work to do that. Bottom times derivative of the top, da-da-da-da-da. And you come down and you get this as your derivative. Then you're going to plug in 1 for t, and you get this. If you plug in 10 for t, you get this. Now, I'm going to show you how to do this particular thing on a calculator, because we'll do plenty of derivatives where you cannot use the calculator. But sometimes, particularly on applications where you're asked to find a derivative at a certain point, at a certain x, which is what you're asked to do here, you can use your calculator. So let's look here. So with the calculator, if you have an older TI-84, if you hit math and 8 is in deriv, and that's the function that'll come up. And inside, in these parentheses, in this right here, we're going to put the numerator divided by the denominator. That's your function. We're going to put a comma. We're going to put our variable x, comma, and the first part would be we're evaluating it at 1. Now, for newer versions of the calculator, if you hit math 8, you get this nice icon here. And so all you have to do is fill in. And here I've shown you how it fills in. You put an x in this little box here, because that's derivative with respect to x. In this box, you put the function. So there I've got that. In this box, you've got x here equals, and you put the number you're evaluating. So you would do it with 1, and then you could just come back and do it with 10. But you're going to get the same thing. I've shown you doing it by hand, but I am totally okay with you using this method when you're evaluating when you're doing a numerical derivative, meaning you just got to get it evaluated at 1 and evaluated at 10. So that is open to you for number 9. Let's now look at number 10, and we won't be able to do this one with the calculator. So this one does have some work to it. This is your last question. It is number 10. The total cost in hundreds of dollars to produce X units of a product is. So here's our cost function. It is a quotient. Find the average cost for each of the following: 30 units, X units, and then marginal average cost. Well, remember, when we have marginal, that means it's a derivative. These two, we're just doing some algebra. So average cost is the total cost divided by the number of items. So if you're doing 30, you want to substitute that for X units. So 3 times 30 minus 5 over 5 times 30 plus 3, that's 85 over 153. Now, that's the cost of 30. But average cost, now we've got to divide this thing by 30. And if you do that in your calculator, you get this decimal. Putting that in money terms, that's $1.85. We moved the decimal over 2 places. So we just plugged in this number here. We got this as our cost. That's a cost function. But they're talking about average cost. So we have to divide by the number of items. So we divided this by 30. And we got that. All right, the average cost for X units, we've got to divide by X. Well, dividing by X is the same as multiplying by 1 over X. That makes it easier for this one. So that becomes that. And here we're multiplying X times both of those terms. This is the answer. That was pretty easy. Now the marginal cost is the derivative of the average cost function. So this guy here, we have to take the derivative of. And we're not doing it at a particular number, so we can't do it on the calculator. We got to do the whole thing. So bottom times derivative of the top. Let's go ahead and keep that theme going here. And minus the top times derivative of the bottom over the bottom squared. That derivative is 3. That derivative is 10x. Down here, we go ahead and do the multiplication for both of those. Then we'll distribute that minus we've got here. We'll collect any like terms that we have. So we had a negative 15x squared. We had 50x, and we had 15 divided by the bottom squared. That's the derivative of the average cost, and that's the third part. So there were 3 parts to that. The first 2 were just algebraic. You're just doing some algebra here. The third one was marginal cost, which meant we had to do a derivative. And that should finish up 12.2 for you.